Suppose we're asked to graph the sine of negative 8x. Recalling what we know about graphs from algebra, when we replace our x with a negative 8x, we expect a reflection about the y-axis. Right? But in trigonometry, we can make this a little bit easier on ourselves by taking advantage of the evenness or oddness of a trig function. Sine is odd, so I can write the sine of negative 8x as negative the sine of 8x. Okay. And then now that my coefficient on x is positive in the argument, this is something that I've dealt with before. Right? So I can find the period. It's going to be 2 pi over the absolute value of the coefficient on x. We made that positive, so that's just 8. So the period is pi over 4. Amplitude, I have negative sine of 8x. The absolute value of negative 1 is just 1. So the amplitude is 1. And now I have enough information to draw my graph. Mark off my period. And then cut it into fourths. So pi over 16, pi over 8, 3 pi over 16. And then put in those quarters on the negative side as well. Drawing my amplitude lines. Alright, and we're graphing negative sine here. So we're going to start at 0, 0 and go down. So on the left side we'll go up. There's our graph for sine of negative 8x. Notice in this trick, if we were graphing something like cosine of negative 8x, cosine is even, so we can write that as equal to cosine of 8x, right? So using these manipulations, right, I can rewrite my trig function so that the coefficient on x, the b, is always positive. Right? And so we've been talking about taking 2 pi and dividing by the absolute value of b. Using these tricks, we should be able to turn it into something where that b is always positive.